Okay, so an empirical formula. It's just the simplest whole number ratios that's in a chemical formula. Okay, I'm going to show you some examples of some that represent empirical formulas and some formulas that are not empirical formulas. And then we'll give the empirical formula for it. So let's just start out pretty easy here, about as easy as you can get. So the ratio, simplest formula for water is 2 to 1. Can we make that a simpler whole number ratio? No. So this is an empirical formula. And the molecular formula for water. They're the same. Okay? Do another one. All right? Here's H2O2.
What's that first?
Yeah. Okay, H2O2, is that the simplest formula? So, by the way, this is hydrogen peroxide. Is that the simplest formula for that particular compound? No. What's simpler? H and O. This is called a molecular formula. Now this is empirical and molecular, this one. Okay? But this is a molecular formula, and the empirical formula for that, it would be an H and O. I'm just going to put EMP for short. Okay? So I don't have to write it out each time. So the molecular formula for hydrogen peroxide is H2O2. The empirical formula for hydrogen peroxide is HO. Okay, so when we do our calculations today, if we were doing hydrogen peroxide, our ratio we come up with is be 1 to 1 HO. We would not come up with H2O2. We would always just come up with the simplest ratio. Okay. All right. Let me give you another one. You guys tell me what the simplest ratio for this one would be. This is glucose. So what would that be?
CH2O.
CH2O. Okay. So this is called a molecular. And this is called the empirical. And sometimes they're the same and sometimes they're different. You can simplify it. The empirical and molecular is going to be different. If you can't simplify it, they're the same. Okay? All right. So how do we go about doing that? Those are the first two steps. These are percentages. We're going to take these percentages and work backwards. We're going to come up with the original number of moles that were present in the formula. So there's 4 steps. The first step is what we're doing is we're saying we're going to have a compound and we're going to say it weighs 100 grams. We're going to assume our compound weighs 100 grams. How many grams would be zinc then? 52 grams, because it's 52% of 100 is 52 grams. So what we're doing is we're saying we've got a 100 gram sample, and so now we can take our percentages and make them grams. So our units are going to work out correctly. So that's the first thing you would do. Okay? The next thing you would do is you would convert those grams into moles. That would be the next thing you do. So write that out and then we'll have you do that on your paper. We'll have you change the percents to grams. And then we'll have you make each one of those grams represent a number of moles of atoms for each element by converting each one into moles. Okay? So once you guys have that slide down and done, then we'll have you do those conversions. We're finding basically chemical formulas. There's 2 labs that we're going to do on this. One's going to be hydrate, that deals with percentages and moles. And another one's just going to be where we're going to take magnesium and react it with oxygen in the air and come up with a empirical formula for magnesium and oxygen. Okay. Yep, convert. Okay, I can go back to that slide, but to get your information to do those two steps, I'm going to go ahead, write those down. I'm going to do the first one for you. I'm sure you can do all of them. But what we're going to do is we're going to take and convert grams of zinc into moles of zinc. So I'm going to put grams of zinc down here, and up here I'm going to put moles of zinc. So I'm going to get, basically I'm going to take the weight, and I'm going to find out how many moles of zinc I have in that 100 gram sample. So then I look on the periodic table and I find zinc. Zinc is 65.41. Now up here I'm going to put moles, and then I'm going to get my calculated value. I'm going to do that with the next two and their weights. So I got mole counts, moles of atoms that I can compare. So do that for carbon and oxygen, and then finish your calculation. Yes? Yeah. So we can find the number of moles. We're going to take each one and divide it by the smallest number of moles that's listed. So 0.795 is the smallest, so we're going to divide it into itself. We're going to divide it into each one, and what that'll do, it'll bring our whole numbers out. Then we can recognize the ratio. You guys go ahead and do that and see what you come up with for your numbers. So the third step is to take and divide by the smallest number of moles. And you guys have that on your paper, you don't need that shown to you. And I'll go ahead and put step 3 here. So you've done that, correct? So you got numbers that should have came out to be 1, 1, 3. Is that right? So then that's your formula. 1, 1, 3. It actually comes out to be 1.00, 1.01, and then 3.02. And if you notice, those are basically whole numbers, okay? If we round it to the nearest digit, that would give us a whole number, okay? So then our formula for that one would be ZnCO3. Correct? So we would just write the symbols, and if they're 1, we just write the symbol, and if there is a 3, then we use that as a subscript. So ZnCO3. Okay, I'm going to have you do one where it doesn't come out nice and tidy, but at least you can do the first 3 steps, and I can show you step 4 if it does not come out nice and tidy like the 113 did. Okay, sometimes you got to do one more thing to make it correct. Okay? So, and then that'll include a 4th step. So sometimes you can stop at 3, a lot of times you'll stop at 3 and you'll have your ratio. And sometimes you're not going to be able to stop there because it's not close enough to whole numbers to be able to make that ratio at that point. Okay? So, the one I'm going to have you do is 70% iron and 30% oxygen. Do the same steps, 1, 2, and 3. 70% iron and 30% oxygen. Do those. Same 3 steps. Mm-hmm.